Making sure that we, purpose of this do now is to make sure that we are okay with attributes. For a lot of times when I'm teaching you all, I get not a lot of responses, not a lot of like, Miss Jones, I get this, or I don't get this. And so the instructional time, that's your time to ask me questions. That's your time to fully pay attention, to take the headphones, the earpods, the cell phones, all the distractions away, because this is your instructional time. This is the I do, the teacher time, where I'm here to give you the guidance, to give you this. And then when you get your classwork, that's the time for you to try to implement, okay? It's not the time for you to be like, oh, well, didn't know what to do. You have to ask me questions. This class will be really hard if you don't plan on asking me questions, especially when we're learning the material, okay? And that's just a good strategy overall for when you go to college, is asking your professors for help, asking your teachers for help. It's advocating for your own learning. So let's keep that in mind. Here we have some graphs that we're looking at. And just remembering, domain of a graph, just like you read, is from left to right, correct? So domain is asking how far left is this graph going, how far right is this graph going. Okay, so if I look at graph 1, so for graph 1, it goes all the way to the left. What's wrong with that?
I left my pencil in my house.
You need a pencil?
Yeah.
It goes all the way to the left. And so therefore I'm starting at negative infinity. So my domain is starting at negative infinity. So I start at negative infinity. I'm traveling along, bam. I get stopped by an asymptote at negative 2. So therefore I am stopping at negative 2, and it's an asymptote, so I don't even touch it.
Which one are we doing? Are we doing the one on the bottom left?
Number 1?
Yeah, but there's like another one.
This is an entire function. So you're reading the entire function from left to right. What's happening? So I started off at negative infinity, I traveled, and bam. I have to stop here at this asymptote.
Yeah.
Right? Yesterday we talked about when there's an asymptote, that's that or situation, right? I'm looking at this piece of the function, or this piece of the function, or this piece of the function. When or happens, that's where we use the union symbol. So now I'm analyzing this piece of the function. So from negative 2 to positive 2, that's what's happening, right? So then the piece of the domain here is negative 2, positive 2. And then there's another break. And then the last piece here is negative 2, and then I go on forever to infinity. Then positive 2, and I go on forever to infinity. So then I have 2 to infinity. So literally, as you're reading the domain, it's in your notes. You're writing it down.
Yeah, I know, but like, I don't, like, never more got it.
I have a question.
Yes.
So the quadratic function, I think I
So this is not a quadratic, it's just a function.
But the one on the top,
Mm-hmm.
if there wasn't the other two lines, would it be negative infinity, positive infinity?
Yes, so if the quadratic was the only thing on this graph, then it would be an all real number situation from negative infinity to positive infinity. But because the graph is in section, as I read, I'm breaking it up. And that's what domain is. As you're reading from left to right, what is taking place? And that's all you're focusing on. Literally, you're looking at, am I starting? Am I stopping? Am I starting? Am I stopping? Okay? And the reason why we have these breaks here are because of the vertical asymptotes. Those vertical asymptotes are causing me to stop. And it's breaking my graph in sections. Yes?
Isn't it reflectional symmetry?
Yes. When we get there. Mm-hmm. Perfect. Now your range goes from bottom to top. So starting at the bottom, what is the lowest that your y values can go to? Negative infinity, right? The lowest my y values can go to is negative infinity. So I'm starting at negative infinity and I'm traveling, and then bam, at 1, I have an asymptote. So I have to stop. So the range on number 1 is negative infinity to -1, and then I stop. And I'm stopping because there's a horizontal asymptote. That horizontal asymptote is causing me to stop. And then after -1, I continue to go. I'm going, and there's nothing else stopping my y-axis, right? There's no other horizontal asymptote, there's no break, no gap, no anything stopping my y-axis. So my y-axis is continuing on to infinity. So my range would be -infinity to -1, union -1 to infinity. The only intercept I have is at the origin, at 0, 0. My asymptotes. I have 3 asymptotes. How do I know I have 3 asymptotes? Well, looking at my breaks in my domain and my range, something's up, right? And if I look here, you see those dotted lines, those imaginary those dotted lines are my imaginary boundary. So I have asymptotes. I have 3 of them. I have vertical asymptotes at x equals -2 and x equals +2. I have horizontal asymptotes at y equals -1. Do you see where those do you see where the asymptotes are? Those dashed dotted lines represent my imaginary boundary line. Okay? So maximum and minimum, because this graph has a point where it can go all as low as -infinity and as high as +infinity, I do not have a maximum or a minimum. Unless I was on a specified interval. And I think we already had someone tell us what symmetry it was and what type of symmetry is it. Okay? So it's reflectional because if I take my hand and I put it down the y-axis, is it evenly divided? Could I fold it and it mirrors itself? Yes, so it would be reflective. This is what you're expected to do when you're analyzing a graph. You're taking the domain, analyzing the domain from left to right, analyzing your range from bottom to top. Intercepts should be pretty straightforward. Do I cross the x-axis or the y-axis? Maximum and minimum. Do I have an extreme high that I can't go past? Do I have an extreme low that I can't go past? And symmetry. Remember, we have rotational and reflectional. This is what you were practicing, what we've been doing for the past 2 days with our parent function, and what your classwork and practice assignments have been over. Okay, this is just for graph 1. For time's sake, we're not going to do graph 2 because we've already spent a lot of time on this. But it'll be available for you to do if you want to go back and try and practice and let me check your work. But questions, comments, concerns about domain, range, intercepts, maximums, minimums, symmetry. These are your key things, your key attributes you should be able to identify. Alright, so we're going to do our parent function, our last of our parent functions. Yes! Hallelujah. So the last of our parent functions are our exponential and logarithmic functions. Okay? It's 6 of them. They're going to go fairly quickly because they share similar properties. Alright, so parent function attributes, exponential log. It's going to go fairly quickly. It may feel like a lot, but a lot of the attributes repeat. Okay? There we go. We have it with base e. So this is our base that we're going to be using. So we have f of x equals e to the x. Okay? And exponential means your variable is your power. An exponential means your variable is your power. For the ones in class, you fold it in half, and if you remove the stapler, it should make a little booklet for you. And then it's a flip book. So when we look at this graph, we're going to look at a couple key points. Notice here how my y-intercept is at 0, 1. And even though it looks like I'm touching the x-axis, I'm actually not. There's an asymptote on the x-axis at y equals 0. So I'm getting as close as I can, but I'm actually not touching the x-axis. Okay? And that's because there's a horizontal asymptote here, remember? HA, horizontal asymptote. E is like pi. It's a number. It has a value. That's the best way. E is a number. It's not just nothing. So domain. The domain here, from left to right, what is happening? All the way to the left, I'm where? I go on forever, so that's negative infinity. And I go all the way to the right. So my domain is all real numbers. Your range, so what your range is doing, your range goes from bottom to top. What is the lowest I go as far as the range? 0. So it's an asymptote. So it's a parenthesis, not a bracket, because the asymptote, I don't have a value there. Because of the asymptote, I am not going to have any x-intercept. That asymptote prevents me from having an x-intercept. I do have a y-intercept at 0, 1, and I have a horizontal asymptote at y equals 0. I do not have a maximum nor minimum, and I have no type of symmetry. Do you agree with the statement so far? Do you see where that's coming from? If not, either write a comment or on the sticky note to ask me later. That's what you do. Okay? Inverse function. The inverse of this is called the natural log. Natural log of x. All right, so for the next three, what's going to happen is that the properties are going to stay the same. What's going to change is their inverse, but all the properties are going to stay the same for the next two exponentials. Okay? So let's look at exponential 10. So now I have a base 10. So we have f of x equals 10 to the x. Okay, notice here how I have 0, 1 still. I also have on here 1, 10. My asymptote is still at y equals 0. Can you see that? So, looking at all of this, do you see why all the other properties are going to stay the same? The only thing that changes is the steepness. The steepness of my function. That means I'm growing faster, right? So the function is now growing even faster. So the steepness has changed. But everything else is still all real numbers, still from 0 to infinity, still doesn't have. My y-intercept is still at 0, 1. My asymptote is still at y equals 0. I don't have, I don't have, I don't have. And that's because it still is an exponential. My base is what's changed. The inverse function here is f negative 1 equals log of x. Okay, there is an unspoken, on some of the newer calculators you have to put the 10, but there is an unspoken little 10 here. It's a subscript. It's log subscript 10. Okay? But the properties are still the same. Our last exponential is, we're going to use 2. This is going to be our base just for the model of this graph. So for the model of this graph, we're doing base 2. So this is y equals 2 to the x. But the function itself is f of x equals b to the x. Okay? And b is greater than 1. Okay, so if you look here, what happens, I still have my asymptote at y equals 0. I still have my y-intercept at 0, 1. Does anyone know why 0, 1 is always a y-intercept? What's anything to the 0 power? 1. So if I plug in 0 as my x, anything to the 0 power is 1. And that's why for all the exponentials, 0, 1 is your y-intercept. Make sense? All right. So 0, 1. Then notice here on my 2, when I go to 1, what's anything to the 1 power? If I ask for 3 to the 1 power, you should say, not a trick question. It's 3. Anything to the 1 power is itself. So if I have 5 to the 1 power, 5. If I have a million to the first power, it's a million. Okay? Anything to the 1 power is itself. So if you look here at x equals 1, notice that I'm at 2. Notice on the base 10, I was at 10. So what this tells us is that our 1 is going to always be 1 comma whatever your base is. If my base changes to 5, then that value will be 1 comma 5. If my base changes to 20, then that would be 1 comma 20. For this problem, our b is 2. You see that? Yeah? Okay? All right, everything else stays the same. Domain, negative infinity to positive infinity. Range, 0 to infinity. No x-intercept. Y-intercept is still at 0 comma 1. Asymptote, still at y equals 0. No maximum. No minimum. And no symmetry. My inverse function is f of x, inverse of x, equals log subscript b of x. So it's log base b, whatever that b value is. So for this function, its inverse would be base 2, right? So inverse here would be log base 2. Because my b value is 2. Okay? So those are your exponentials. Now we're going to do our logarithmic, our log functions. And we're going to do e 10 2. So log e, so f of x equals log base e of x equals what's called the natural log of x. This is called your natural log. How many of y'all have seen that LN button on a calculator? log natural. That's how I remember it. Okay. And now, because it's the inverse of e to the x, instead of having horizontal asymptotes, what are we going to have? Vertical, because the opposite of horizontal is vertical. So now we're going to have vertical asymptotes. So I have a vertical asymptote at x equals 0. And that's going to be it for all paired functions of log. This time, instead of 0, 1, what point, if it's the inverse, what happens to my x and my y? They switches. So it's going to be at 1, 0. So now I'm going to always have a value of 1, 0. Okay, so now that means, because this is the inverse, literally my domain and range are switching places. So my domain here is now 0 to infinity, and my range is all real numbers. That's what happens to inverse functions, which we're going to dive into a little deeper next week. How do you feel? Okay, x-intercept. So I have an x-intercept now instead of a y-intercept. And I don't have a y-intercept. I probably should write your name. So I just realized I put x's everywhere. You're like, why are you putting x's everywhere, miss? Not a smart move for an algebra teacher. Asymptotes. So on asymptote, instead of having horizontal asymptotes, I now have vertical asymptote at x equals 0. There's no maximum and no minimum because I'm going on forever. And I still have no symmetry. And my opposite twin, my inverse function, is e to the x. Yep. That's why we learn them together, because they're besties. All right, so log of base 10. So now we have log. And because it's our base 10, we're going to write it with the x, but on the standard calculator, it is just the log button. Okay? On your Inspired, if you leave the subscript blank, it's going to treat it as base 10. Okay? This is called our common log. Common log. Okay, so when I look here, everything is still the same. I have vertical asymptote. I have my x-intercept. And now, instead of having 110 as a point, I have what? Instead of 110, because it's the inverse, I have 10, 1. And then all of my other attributes are the same. 0 to infinity, negative infinity to infinity, x-intercept at 1, 0, no y-intercept, asymptote at x equals 0, no maximum, no minimum, and no symmetry. And the inverse of the common log is base 10. Base 10 to the x. I wrote 10 there, don't know why. I wonder if I can just, I've got a big old list. There we go. So smart. Is the 10 to the x exponential? Okay. last one. So we have, this is our b. So b is 2. So we're going to have log base 2 to the x. This is with anything log base b. Okay? But in this case, our b is what? 2, so that we can have a graph. Because you can't graph log base b in the calculator. So notice here, I still have my asymptote at x equals 0. I still have my my x-intercept at 1, 0. And now, if you look right here, instead of 1, 2, I have 2, 1 as a point. And what this tells me is that whatever the b value is, it's going to be b comma 1 will be a point. Whatever the b value is, I will have b comma 1 as a point. However, all attributes are the same because I'm part of the logarithmic family, right? All of my attributes are still the same from the previous two. 0 to infinity, negative infinity to infinity, 1, 0, no go, at x equals 0, no go, no go, and no symmetry. And my inverse function for all of these would be b to the x. The inverse for the specific function I have here equals 2 to the x. Because what is our b value? 2. And those are your logs. An exponential note.